Go.
Cellular respiration occurs in the mitochondria of plants, animals, and some bacteria. They first start with a glucose molecule, represented here by our cheese puffs. Now, we're going to take away an ATP from this molecule, represented by the yellow gumdrop. And we're going to add phosphate. Now, we're going to pull another one. So a total of 2 ATP have been extracted from the glucose, and we're giving them another phosphate. Now, they're going to break apart and go their separate ways. And we're going to have NAD, and they're going to take 2 electrons away each and make NADH. Now, by doing that, you're adding a phosphate on either side. Again. So now, and you take away your NADH. They float away. Now, what you're going to do is you're going to take ADP away from both of these molecules and create ATP, which will remove a phosphate from either side. Now that you've done that, they'll end up rotating to even themselves out, so like this. Like so. Now, they're going to extract water, H2O, out of these, and then, represented here by the purple ones, you take those away. Now, you are going to take ADP again to make your ATP, taking away your final phosphate, leaving you with 2 pyruvates.
As the pyruvate conforms with the NADH, it forms the coenzyme A, which starts the Calvin acid cycle.
In the Calvin acid cycle, only 2 carbons enter the cycle. Now, they form a string of 6 total carbons, or a molecule known as citrate. And you'll take an NAD molecule, and it'll take out 2 electrons, and each time it takes away 2 electrons, ATP is made. But the first time this is done, a carbon leaves. A carbon leaves the group. So you take 1 carbon away every time ATP is made. Got your ATP. Now it moves again down the cycle with only 5. Then it takes another carbon away. Then making another NADH. Making another ATP. Now, you keep doing this until you're at the very end. In the very end, they only have 4 left. You should only have 4 carbons left. So, by the end, you should have 2 ATP, 6 NADH, and 2 FADH.
After all of the hydrogen left from the glycolysis in the citric acid cycle is transferred or carried to the electric transporting chain, which starts the process of making more ATP. And then you start there.
Okay. Alright, now let's say this is the electron transport chain. For electron carriers, hydrogen, represented by these, are slowly being pushed out and pulled in. Okay. Now, NADH, and it's flowing down the electron chain, and these are electrons. They're moving down the concentration gradient. So